Now imagine you have a collection of texts that you want to search over. And of course, you can't just take your texts as they are, put them somewhere and have efficient search. First, you need to pre-process your collection. And the pre-processing is relatively straightforward. Maybe you have seen it before. So first, you need to remove all the white spaces and punctuation. Essentially, you need to extract words or lemma, well, words, tokens, we sometimes call them, or terms. Second, you convert all the terms or words to lowercase. Remove stop words. We will touch on that a bit later, what stop words are in case you don't know. Then you do stemming, convert terms into stems. Again, we will talk a little bit about that. And then, importantly, you should deal with phrases. I'll also explain why. That might be important. Maybe not for your assignment, but in general, phrases they need to be dealt with. And of course, depending on your language, if it's English, it's one set of processing rules. If it's Russian, it's another set of processing rules. If it's Chinese, it's again a little bit different pipeline. So of course, you have to do some language-specific things, but we will discuss from 3 to 5, this stop words, stemming, and phrases, because those are the most important, the most common. And by the way, when you do your assignment, you can just play with it. You can create different indices with stop words, without stop words, with stemming, without stemming. Actually, you will do a little bit of that in the assignment, and you will see how pre-processing actually affects the final performance of your search. All right, some very simple example. Here we have, let's say, a text that we need to prepare for indexing and then for search. First, what we do, we remove punctuation and we lowercase. So we remove comma, we remove full stop, we lowercase here. Then we remove stop words. Now, stop words are the words that occur very often, that occur in almost every document. And since they occur in every document, they don't distinguish between documents. So if you search for word 2, you should extract the whole collection, because almost every document contains the word 2. So the word 2 is not representative of the text. So you drop things like 2, 4, 1. How that is done, it's on the next slide. So you drop those. Here I decided even the text is a stop word. It may be not, and word is a stop word. Maybe it's not in some applications, in some it may be a stop word. And finally, you do some sort of stemming. In stemming, again, this is a certain specific stemming that I did. You can do different types of stemming. Here, I dropped all the suffixes and endings. So I dropped E here, I dropped the suffix ing, I dropped the ending S, ing, E here, and so on. So that's how I got something that we call stems. Now, talking a little bit about stop words. How do you detect that a word is a stop word? Well, a natural approach is you say, okay, I set a certain frequency threshold. Let's say if a term is more frequent than 1 million occurrences in my collection, well, it occurs more often than 1 million times, then I consider it a stop word. And so you just say all the high frequency up to 1 million, down to 1 million I remove, everything that is below 1 million I keep. Of course, you can use dictionary-based, where you actually yourself create the dictionary, where you say, okay, 2 is a stop word, there is a stop word. And for example, if you have domain-specific collection, maybe sports-related collection, in that collection, the word sports may occur in every document. So you may say that the word sports is a stop word for the sport-related collection. Or you, of course, can combine the two. You can create a dictionary based on thresholds, for example. So this is pretty straightforward, and that's how you deal with stop words.